Okay, let's calculate those three components. The first that we'll do is hang time. How long was the object in the air? To figure that out, you kind of have to talk to the equation and say, at what time does y equal 0? Well, to answer that, you just go to the y component of the position and you set it equal to 0. And maybe we'll put a subscript h for hang time. We're finding a specific time when we do this. So that component, the y component, was vi sine theta t, so th, the specific time, minus 1/2 g th squared. When does that happen? At th, it's at 0. So now we just solve this for th. So you'd probably factor it. So th times vi sine theta minus 1/2 g th, right? Because it was squared, so you pulled one out, equals 0. And if we want to solve this for th, well, one solution is if th equals 0. But that's not the hang time. Did it give us an incorrect solution? No. At time equals 0, the y position was 0. That's the beginning of the trajectory. This is the one we care about. When is this term 0? This term is 0 when we solve it for th. Bring the 2 over here. Looks like it's the hang time must be 2 v initial sine theta over g. So there's your first one, hang time. That's how long it's in the air. The faster you shoot it, the longer it'll be in the air. The bigger the angle, the longer it'll be in the air, and then the slower gravity is, the longer it'll be in the air. Let's look at the range. That's the critical one. How far does it go? Now, I'm doing my order on purpose here because how far it will go depends on how long it's in the air. So to calculate the range, how far in x during th, you really just have to say we'll use the symbol r to represent the range. It's just the horizontal velocity, which is constant. There's no acceleration. So the horizontal velocity is, of course, just vi cosine theta times t. But t is the hang time. So times 2 vi sine theta over g. Okay? And you combine those and you get, so the normal way to write it is the 2 vi up here times sine theta cosine theta over g. And I forgot that there's 2 vi's squared, sine theta cosine theta over g. All right, there's the range. One thing you can learn from the range is what angle do you want to shoot at to get the maximum range, and from this you can tell it's 45 degrees. If you plot sine cosine, the biggest value is at 45 degrees. If you go to 90, one of them's 0. If you go to 180 or 0, one of them's 0. So halfway is where it maximizes. And then finally, the height. How high did it get? Right, the height is basically y at 1/2 th. Right? Thy has gone to 0, but since the trajectory is symmetric, you know that it's going to be the maximum right in the middle is the easy way to get there. So all we really have to do is get our y expression and plug in 1/2 th. So vi sine theta 1/2 th minus 1/2 g 1/2 th squared. Right, that's the height. So let's start plugging in. There's a little bit of algebra involved, but there's nothing wrong with that. 1/2 th just takes that 2 away, right? So it's vi sine theta over g. So let's plug in vi sine theta times vi sine theta over g minus 1/2 g. And here we're just going to have this thing squared, vi squared sine theta squared over g squared. Vi squared sine squared theta over g squared. Whew, what a mess. And what do we got left here? Both terms have vi squared sine squared theta in the bottom. Both terms have a g in the bottom because this g cancels that g. So So it's really the same term minus 1/2 of itself. Right? So if we want to do the algebra in one step, we would say it is 1/2. Well, let's put the 2 in the denominator. It's vi squared sin squared theta over 2g. There you go. That's how high it's going to go if it's a nice symmetric trajectory. So if you're taking a physics class and you're going to have to take exams, you got to decide, do you want to memorize these or do you want to be able to derive them quickly in an exam? So of course in physics we care about deep understanding. We don't want you to memorize things, we want you to be able to derive them. However, in an exam, if you have a limited time, it's often good to have have equations at your fingertips. And fingertips at your equations is also good. But you want equations at your fingertips so you can get through a problem faster and not have to conceptualize a problem and then stop to rederive the range, right? That would take forever. So these are kind of worth memorizing, and it looks hard to memorize them until you realize that they're almost all the same, right? If you think of them as all in terms of vi sine theta over g, this is like 2 vi sine theta over g. This is vi sine theta over g times 2 vi cosine theta, and this one is just sort of that squared. Right? So they're a little bit similar, not too hard to memorize.